Hello guys, today I am going to explain about n queens problem in LeetCode. The question is the n queens puzzle is the problem of placing n queens on an n into n chessboard such that no two queens attack each other. So we have to consider this, no two queens attack each other. So we can see this here. This is if we say this is the queen, this is not attacking any other queen. First of all, what we can say is attacking queen attacking in the sense, I'll take a board here. See, if we want to place a queue here, we have to check from the all 8 direction, from the top direction, down direction, and left, right, and top left diagonal, top right diagonal, and bottom left diagonal and bottom right diagonal. So we have to consider all these cases. If we place any queue here, let's say if we place any queue here, it will attack this queue. So this is what should not happen. Okay, that is a question they have given here. Given an integer and return all distinct solutions to the n queen puzzle. You may return the answer in any order. So we have to return the distinct solutions. Means like the each solution should be different from the other solution. Each solution contain a distinct board configuration of the n queens placement where q and dot both indicate a queen and an empty space respectively. Here we are denoting our queen with the q and the empty spaces with the dot. So this is the example. See, if we see this q, this is not getting attacked by the any other q. See, this is left, this is right, this is top, and this is this is top, this is bottom, and you can see the diagonals also. You can see my cursor point. So this is not getting attacked by the any other q. So like this we have to arrange our queens. So I'll give another example also. So see, this is the directions. We have to check if we want to place any queue here. See, we have to see all these directions, all the 8 direction, but actually we should not consider in this problem. The 4 directions are enough to check, because here we are going with the row by row. In each row we have to place only one queue. Say for example, I am taking a 4 into 4 board. See, first I will place q here. So this row is done. So next I want to place my another queue. I want to place my next queue. So if I place my next queue here, it will get attacked by this queue. So I cannot place this here. Okay, I'll go here. I can place my queue here, and I will check this. There is no queue in the left, no queue in the diagonals also, and the top and bottom also. So this is the correct place. And next I want to place another queue in third row. So if I place here, it will get attacked by this queue. So I cannot place here. If I place here, it will get attacked by this queue. So that's why I cannot place here also. If I place here, so it will get attacked by this queue. So I cannot place here also. And if I place this queue here, it will get attacked by this queue. So I cannot place here also. So what I can do is I will go, we can come to know that this queue is not in its correct position. So we have to change this position. So I will remove from here and I will place that queue here. And next, okay, I want to place another 2 queues, right? So I will take I will try to insert my another queue here, but it will get attacked by this queue. So I cannot here. So if I put my queue here, it is the correct position, because the diagonal stop and there is no another queue which will attack this queue. So if I come to this row, I cannot place here. So because this queue will attack this queue, so I cannot place here. I cannot place here also because we are having queue on the top, which will attack this queue, and I cannot place here also, so which will attack by this queue, and I cannot place here also because this queue will attack this queue. So what I have to do is I will again backtrack, and for this we are done with all these positions. So I will go to my first queue and I will change this queue's position. So I will change this queue's position. So I will place my queue now here. So I will place queue here, and this is okay. And next, coming to this row, I cannot put my queue here, I cannot put my queue here, I cannot put here also, and I can place here because it will not get attacked by this queue. Okay, and coming to this line, I can put my queue here because which is not getting attacked by anything. Yeah, okay, this is also fine. And next, coming to this last row, so I cannot put here because it will get attacked by this queue, and I cannot put here also, and I can put here because, okay, I'll check this diagonals also. So here also there is no queue, and here also there is no, here also there is no, and here also there is no, and in this diagonal also there is no any queue which can attack this queue. Okay, so we can say this is one of the solution. In 4x4 board. So like this we can find the multiple solutions. One is here, one is here, yeah, another one is here, and another one is here. So like this how we have to place the queues. What I can say is, what are the positions for this we have to consider is, while we are putting only, we are checking four directions. Okay, I'll tell in this only. See, in the initially only for this we are checking. For this we are checking top and diagonals and left also. So we can so there is no need of checking the right and downward left diagonal and downward right diagonal, because if we are at this position means there is no queues in these positions, so we don't have to check all the 8 direction. It is enough to check 4 directions, or else in the left side also there is no need to check, because if we are placing only one queue in one row, because so what you can say is 3 directions are enough to check. I hope you have understood this. So after we got solution, we are making this to be the dot. So because to get the multiple solution, we will from where we got this queue, we will again go back to that queue, and for that also we put the dot, and likewise we will get all distinct directions. We will get all distinct directions. I hope you have understood this. I will just start coding this. So the return type is list of string. So list of string. So I am taking a result to store my result. So first what I'm going to do is I'm taking a board of type character. I'm taking a board equals to of size n into n, and we have to consider one thing, that board should be n into n, of size n into n, and I'll start a loop, and initially I will fill that board with the dot. So board of I and j equals to, first I am putting the dot operator, and now I will call this solve NPins function. So what I will pass here is, I will pass my board and row and n, and I have to store the result, right? So I will pass that also. I will pass my result also, and finally what I am going to return is, I am going to return my result. So now I am going to write the function for solve NPins. So first what I have to board of type character, int row, int n, and result of type list string, right? Result. So the base condition is nothing but when row equals to n, we are printing our result, right? So if that condition is, if row equals to n, when my row becomes n, then I am just printing the result. So list, I am taking a list of string to store the each row. So they have given that we have to return the result in the form of list of string. So what, so if you can see this output, so this what I am doing is, I am storing my all the rows in the form of list, and I am adding that to the list. So for that purpose I have taken this string str. So I will do until my I becomes n. So first I will go with first row and next second row, and likewise. So I am taking this string. This is a list. What I am going to store all the rows. So I am going to add that each row into the list, and next I am adding that list to the result, right? Result dot add of list, and I'll just return. So this is for when my row becomes n. So otherwise what I have to do is, I have to check, I have to insert my queen, right? So for that actually we are getting row from the from here, so I am taking column, means like, see, anyhow we are getting rows, so I have to take columns, right? So 0 to our n. So for int column equals to 0, column less than n and column plus plus. So what we have to do is, initially what we are doing is we are checking that whether putting our queue in this row, I mean like in this column, is safe or not. So for that we have to write the is safe. Okay, I'll just so for that what I will pass board a row, column, and yeah. If it is safe, what I am going to do is I am going to place my queue in that position. A board of row, column equals to queue. And next I am again calling my solvent piece, now by passing the row by 1. Now what I will pass is I will pass board. Now row, I am incrementing the row value and n and result also, and board of row, column equals to I am putting dot. So when we backtrack, so we are putting that row column as dot. So now we are left with the isSafe function. So I'll write that the type is boolean here. What are the things I am passing here is board, and next row and column, and my m. So I have told already that we are considering only 3 directions, right? So I'll go with the top one first. If I want to check the top one, what I have to change is I have to keep constant of column, and I just have to change the row values, right? See, for the top, the column will be same as it is, there will be no change in the column, and we have to change our rows. So what I'll do is for top, starting with row -1 until I should not be out of bounds, right? Until that I greater than or equals to 0, and I plus plus. So the column will be same, but we are going to change the row. So for that the board of, we are going to change row, and column will be same. If it is equals to our queue, then we are not going to place queue, right? So return false. So this is for the top. And next, if we go with the left diagonal, see the left diagonal, okay, I'll draw this again. See, if we want our left diagonal, what are the things we have to change is, we have to change our row, column, and as well row also, because if we want to get these index, see we are one above one row and beside one column, right? So for this, what we have to do is we have to take row -1 and column -1 until we find 0. I equals to row -1 and j equals to column -1. I greater than or equals to 0 and j greater than or equals to 0, I minus minus and j also minus minus. So if both of I and j equals to q, I'm just returning false. So we are done with the top and left, and now left diagonal, and now we are left with the right diagonal, right? So for that, right diagonal, let's see what are the things we have to change to find the right diagonals. I'll take another column here. See what are the things, if I want to get the right diagonal indexes, what are the things we have? This is the right diagonals, right? If our q is here, see if we want to place our q here, we have to check these right diagonals. The indexes of these will be like, we are decrementing the row and incrementing the column, but a row should until the row should reach 0 and until our column should not exceed out of n, right? So for this, I equals to row minus 1 and j equals to column plus 1, I less than or equals to 0 and I greater than or equals to 0, and our j should not out of n, right? So j less than n, I minus minus and j plus plus. So if pod of ij equals to q, I'm just returning false. If any one of the case does not becomes false, then what I am just going to do is I will just return true. This is the eSafe function. I hope it is clear. I'll just check once. Okay, I'll just run and see. Line 17. I'll run again once. Okay, we'll see. Yeah, the solution has accepted, guys. I'll just recall once again. So first what we are going to do is we are taking a board of type character, and initially we are filling that with the dots, and again what we are doing is we are calling the solve enquiries. We are passing board, and initially the row will be 0, and we are passing n. Along with that we are passing result to store our result. And finally what we are going to do is we are returning our result. Coming to the solve enquiries. So I have already told that what are the things we are passing here. If when we find that our row equals to n, then we are storing our result, and we are just printing adding that to the result. And next this is for we are getting row, so I am taking here column. So I am taking column, and I am checking whether that row is valid to place my queue or not. So for this what I am going to do is I am writing eSave function. So in that what are the things I am passing is I am passing the board as usual, and row and column. So if we found that it is a valid place to place our queue, I am placing my queue in this respective row and column, and again I am calling the solve enquiries. Now by this time what I am doing is I am incrementing my row. So initially the row will be pointing if okay, initially my row will be this, and by the next time what I am going to do is I am just incrementing +1. So now my row becomes the second one. So and by the next time when I call again the row will be incremented by 1. So next time row will be this. So likewise we are going to call that function, and board of row dot column equals to dot. See, when we find a solution, we are having distinct solutions, right? To get the distinct solution, the last queue which I found, I am making that dot, and again I am backtracking this. So for that I have done that. And eSave function, right? So eSave is nothing but in this we are considering, actually we have to check 8 direction, but what I am doing here is I have just checked only 3 direction, which is nothing but left diagonal, top and right diagonal. So why I am not checking all these other directions is, see, if we are at this position, see let's say if we are at this position, I may not have traveled this direction, and this direction and this direction, right? So that's why I am not checking all the directions. So I have already explained what are the things, which are the things changing while checking the respective diagonals. So if any one of these is false, we are not going to put the queue there. If it is returned true, then we are placing queue there. So this is all about this solution, guys. Thank you for watching.